Hey everyone, it's Michael Kenter. In the last video, we talked about petals and floras and state hashes. And today we're going to talk about the adapter registry, or HCS21, which provides a brain on top of the appnets, or a plug-and-play adapter system, so that these floras actually have something to come to consensus about. So let's dive on it. So with the appnet standard, we have a shell. Essentially, we built a design where you have these individual accounts. These individual accounts can come together and then they can create consensus on something that they agree on. The thing is, HCS 16 is intentionally left quite open, so you can use that implementation in many, many different ways. You can even augment it for your use case in some capability. Now, they are a powerful coordination engine, and they provide the body for how you manage these multi-sig accounts who are, again, ideally geographically independent, the communications channels and the state storage. But without a body, the brain can't act. So they need some kind of shared logic. So these shared software that each petal runs has something that they can agree on. This way, they can process the information deterministically. Or in other words, we have a quorum, but what are we voting? Right? So with HCS21, we're essentially creating this logic system, or, if you've ever played any video games, and in the old days, like a Game Boy, you popped in a cartridge into your Game Boy and then you had your game. So adapters are very similar to that. They're basically these cartridges that you pop into your appnet. They have the source code, the schema, and the consensus logic that you need to process the data that you're interested in. Whether it's fetching Oracle price data for a certain asset, verifying credentials, are they valid or invalid, or running an actual AI agent. The adapter ensures that every single node in the Flora, every petal in the Flora, is running the exact same calculation. So one of the, some of the key rules here are, number one, it has to be deterministic. So you should get same input, same output on each of the petals. This is really important. Two, we have these adapters inscribed on chain as manifests. So you can actually pull down the hash of the manifest or the code that's being run, and you can have it one-to-one. This is a way to prevent malicious actors who might be impersonating or pulling in source code that you don't actually want to use. So how does it work? It starts with a flora.yaml file, which defines the Flora account that is running the adapters and all of the adapters that you have available. The ones that you're coming to consensus on. So for example, in this case, you might have an adapter ID for a price oracle, and it might have some config that you pass into that package. Then each petal goes and they pull down the adapter from the NPM registry. They check the checksum that it matches, and then they pull down the package and they run it. Now, at each epoch, let's say an epoch is 2 minutes, every 2 minutes, each petal in the Flora will run the adapter, pull down the data, and then ideally they all agree and they get the same data. In this case, if they're all agreeing on the price of an asset, they should get the same price. If they don't get the same price, remember there's a rule that you configure on the floor, for example, a 2 of 3 consensus, then consensus will not be reached and you'll have to go to the next epoch. Thanks, guys.